Ratio. So that's just one vocabulary word that kind of applies to the whole lesson. It is a ratio, which is, it'll be a formula that you see, which is what we'll talk about down here. It's a ratio, so it's written in fraction form. A ratio of the lengths of two sides of a right triangle. We have three of them. We have three. And they're called sine, cosine, and tangent. Okay? So sine, it looks like sin. It's spelled the same way, but we say sine. Okay? So sine, and then this stands for cosine, and this stands for tangent. And if you look on your scientific calculator, you should see all three of those buttons. You should see sine, you should see cosine, and you should see tangent. Okay? So we will be using those today. Now, some of the problems require that you use those buttons, others do not. So, for example, and again, I'm not going to expect you to memorize these formulas. I don't even have them memorized. I can't say that you won't have to memorize them. I mean, they do a little bit of this in geometry, and Coach Agnew's geometry class too. And I'm not sure if he makes the students memorize them or not. I'll have to ask him, or if they can have a formula card. But for the purposes of my class this year, since this is just the first time that we're talking about this and it's introduction, I'm not going to make you memorize them. I would let you have a card where you have this written down. Okay, so the sine of angle A. So we're talking about angle A here. And now the one thing that you should know prior to this lesson is, what is the side opposite of the right angle? It's always the hypotenuse, okay? So for these triangles, we're talking angles and sides. So the angle is the angle measure here, and then the side lengths are here. So you can see from this diagram right here, the angles are listed, they're capital letters. So we've got angle A, angle B, and angle C. And you can see the measure of angle C is 90. Okay, and then we have the side lengths, and they're in lowercase letters. So this means the length of this side, the length of this side, and then C is the length of the hypotenuse. But we don't have them yet, and we're not going to get those. We're just going over the formula right now. Okay? So we don't know what the angle measures are necessarily, except for we know that that's a 90-degree angle. So the sine of angle A, what that means is we can write that as a ratio. It's the side opposite of angle A. So here's the side opposite. Alright? And they give us that, the side opposite of angle A, which is of this little, it's the length of this, which is little a, right here, over the hypotenuse, the length of the hypotenuse. I'm just going to abbreviate. And then what letter represents the length of the hypotenuse? The lowercase c. So if I wanted to find basically you're going to get three pieces of the puzzle. You're either going to get the angle measure and the hypotenuse, and you find the side opposite, or you're going to get a combination of that, and you'll have to use algebra to figure out what the missing piece is. Now the cosine of angle A. So we're still talking angle A here, but now we're talking about the cosine. The cosine of angle A is the side adjacent. Adjacent means right next to. So the side that is adjacent to angle A is B. But we're going to write this here. It's the side adjacent. The side adjacent to angle A, which is B, over the hypotenuse, which is what letter? C. Lowercase c. Yep. Yeah. And then the last one we have is the tangent. The tangent of angle A is going to be the side opposite which again, the side opposite is A, over the side adjacent, which is B. So you see they're all different. We right here, you can do all of the problems that you're going to need to know how to do. And so we'll go over that right here in the first in the rest of the lesson. Okay, so it says in the figure, in the triangle, x, y, z, write the sine, cosine, and tangent ratios for angle x. Okay, so here we go. Here's our triangle, x, y, z. And they want us to write the sine, the cosine, and the tangent of angle x. Okay, so here's angle x right here. This is my angle. So the first one we'll do is well, first of all, they want us to identify the opposite side and the adjacent side. So for angle x, the opposite side is what? 8. Okay, the opposite side is 8. Nice in inches. And the adjacent side, what's the one that's right up to it?
It's
15. Why is it not 17?
because
17 is what? The hypotenuse. Why is it the hypotenuse? Because it's across from the right. So it's across from the right angle. So even though 17, don't let you think that that's the adjacent, because it won't ever be the adjacent if it's the hypotenuse. Okay. So the side adjacent is 15 inches. And then what is the length of the hypotenuse?
it is
17 inches. Okay.
I have a question. What would we do, like, if, let's say if y was the...
Then it would be the same. So if we were finding all these for y, so the side opposite y would be 15. The side adjacent to y is 8, and the hypotenuse is still 17. So the hypotenuse is not going to change.
Okay, so
depending
it
on
will
the
never be
angle.
the hypotenuse.
I mean, the hypotenuse will always be the side opposite the right
And
angle.
is it possible that we'll have one, like, if we were trying to figure out trigonometry with you? Because sometimes there's certain...
No.
Really?
Because no, we always do for the other two. Okay, so if I wanted to know the sine of angle x, I'm going to go back up and I'm going to look at what was the formula, or what was the ratio for sine. It was the opposite over what? Look at your box. The opposite over the hypotenuse. Okay? What length did I say is the opposite? 8. And what length did I say was the hypotenuse? 17. And that's your answer. That's your answer for the sine. Okay? Now, what about the cosine? Go back up to your box and look at the cosine. What was the ratio for cosine? The side adjacent, which, the side adjacent, I'm going to abbreviate, over the hypotenuse. So which length did I say was adjacent? 15. And then what's the length of the hypotenuse? 17. So that's my answer. Okay, now the tangent, go back up to your box. And what is the ratio for tangent? The side opposite over the adjacent angle. Okay, so the opposite was what length? 8. And the adjacent was what? 15. And that's your answer. Okay? So, I mean, again, you're just going to have to use that box to know which one. Okay?
And what about all these questions?
So we're fixing to get to that one. Okay, so example 2 is using the calculator. Alright? So I'm going to go to example 2. And basically, okay, we got our answers, in example 1, we got our answers as fractions, right? All fractions can be written how? As a decimal. When we use our calculator, it's going to give us the decimal version of the fractions we just got, okay, which is fine. So, now, again, every calculator, you may have to push the buttons differently, okay? I'll show you, the calculator I've got on my computer, and again, if you don't have a scientific calculator, but you have a smartphone, you can download, there's several free apps that I found that are scientific calculators on your phone. Now, if you have an iPhone, you don't have to download anything. All you have to do is go to your sine, cosine, tangent. So I think sine, so you hit that one first and then 60. Okay. Now, we're going to do this practice together. If it tells you to write the ratios, okay, so see the directions for this one? It tells you to write the ratio. So you will write it as a fraction. You will not use your calculator, okay? So you're going to have to flip back to that first box, and it says, write the sine, cosine, and tangent ratios for angle P and for angle R. So let's start out with angle P. We're going to start out here, and we're going to do the sine, the cosine, and the tangent, okay? So the sine was the side opposite over the hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is the opposite over the adjacent. Okay, so see how I just copied down what the ratio was? That's all I did. Yes?
For the calculating, would it be like one answer, or do you have to write it all?
No, there's three separate answers.
So
You would have to put the sine equals this, the cosine equals this, and the tangent equals this. Yeah. Okay, so this problem, we're actually ending up with 6 different answers. Because we've got to find the sine, the cosine, and the tangent of angle P, and then we have to do it again for angle R. So let's start with angle P. Angle P is right here. Okay, I'm going to find the sine. The sine is the opposite side over the hypotenuse. What's opposite of this angle? 12. 12 is opposite, right? Now, what is the hypotenuse? 37. And there's your answer for the sine. Okay? Now, the cosine is the adjacent over the hypotenuse. What side is adjacent to P? 35. And then what is the hypotenuse? So there's my answer for that. And then the tangent. The tangent is the opposite over the adjacent. So what side is opposite of angle P? 12. And then what's the side that's adjacent? 35. So my answer would just be 12 over 35. So I'm done with angle P. Now I've got to do angle R. So what I'm going to do, so I don't get confused, is erase my marks here, okay, and use a different color. So now I'm looking at angle R. I'm going to use the same formulas, the same ratios, except they're going to be different because I'm looking at a different angle. Okay, so for the sine of angle R, the sine is what? The opposite over the hypotenuse. So what side is opposite of R? 35. And the hypotenuse is, guess what? It's still 37. It doesn't change. Okay, so there's my answer for that. And the cosine is what? The cosine is the adjacent over hypotenuse. So what length is adjacent to R? 12. And the hypotenuse is still 37. So there's my answer there. And then the tangent, okay, the tangent is the opposite over the adjacent. So what side did I say is opposite R? 35. And what side was adjacent? 12. And guess what? I can leave it just like that, even though it's an improper fraction. And that's it. Okay? Now the second set of practice problems is your calculator. Okay? So all you would do here is some calculators, like yours, you type in sine first and then adjacent, and hypotenuse. Okay? So what we're going to do is if by finding the cosine of 25, I can figure out what the adjacent side is over the hypotenuse. And what length is the hypotenuse? 9. Okay, so we're going to have to work backwards here. So on my calculator, what I would do is I would type in, or I would write, okay, this is, I know the cosine of 25. Oh, we need to figure that out what that is. So I'm going to go to my calculator, and I'm going to type in 25, and I'm going to hit cosine, which I'll just round to the nearest hundredth, 0.906. 0.906. Okay, so what I'm doing is I'm saying, what's being done to x? It's being divided by 9. What's the opposite of dividing by 9? Multiplying by 9. So if I multiply both sides by 9, so if I take that number, 0.906, and I multiply times 9, I get 8.15, and we'll round 5. And that equals x. So the length of this right here is 8.155. Now, does that make sense? Is that close to 9? The hypotenuse is always the longest side. Is it a number that's relatively close to 9 but not greater than 9? Yeah, so that makes sense. So on those, and we'll do some more practice of that. Here's another practice of that. Okay, it says find the value of x in the triangle. Round your answers to the nearest hundredth. Okay, so let's look at what we know. I know the angle measure. What else do I know? The hypotenuse. And what am I needing to find? X. And what is the relationship between x and 50? Is it the opposite? Is it adjacent? We know it's not the hypotenuse. It's adjacent. So flip back to your first page and look what ratio has the hypotenuse and the adjacent in it. The cosine. So we're going to use the cosine again. Okay, so we're going to say the cosine of angle 50 equals the adjacent over the hypotenuse. Now we're going to fill in what we know. Can I figure out the cosine of 50 by using a calculator? Yep, I can. So I'm going to type in 50, I'm going to hit cosine, and I get 0.643. That equals, do I know what the adjacent side is? What is it? It's x. So I don't know that. Do I know the hypotenuse? It's 5. So when I get this answer, it should be a number that's close to 5, but not greater than 5. Now, what's being done to x? What's the opposite of dividing by 5? Multiplying by 5. So now I'm going to multiply both sides by 5 times 5 times 5, right? So I'm going to get 0.643 times 5, and I get what? 3.215. Is that close to 5? Is it greater than 5? No, so it seems like a reasonable answer. Okay, on that one. Last page. Okay, last page. Alright, now we're going to use the sine ratio. It says a skateboard ramp is 45 inches long and makes a 38.5-degree angle with the ground. Find the height of x of the skateboard ramp. Okay, so I know this angle. What is 45? It's the hypotenuse, and I need to know what? What side do I need to know? The adjacent or the opposite? The opposite. So flip back to that first page. Which ratio has the opposite and the hypotenuse in it? The sine. So I'm going to set it up the same way that I set up that other one. Okay? So the sine of 38.5 equals the opposite, which is x, over 45. Now, ask yourself, what's being done to x? That's being divided by 45. What's the opposite of dividing by 45? Multiplying. Now remember, I can go ahead and find out what is the sine of 38.5. 38.5 sine. And I get 0.6 45, what's the opposite of multiplying by 40? I mean, dividing by 45? Multiplying. So if I type in this times 45, what do I get? 28.013. 28.013. And that's it. That's your answer. Now, and does that sound reasonable? Yeah. Last one. It says a climbing net makes an angle of about 64 degrees to the ground and attaches to a platform. The net extends horizontally about 6.3 feet. What is the height of H, the platform? Okay, now look at, we know this angle measure. This side right here, is that the opposite or the adjacent? Adjacent. Do I know what the hypotenuse is? No. I need to know what side. The opposite. Right. Okay, so flip back to that first page. Which one has the opposite and adjacent in it? Tangent. Okay, so I'm going to say the tangent of 64 equals the opposite, which is H, over the adjacent, which is 6.3. And again, I'm going to hit tangent 64 tangent, which is 2.050. 2.050. Now, what is being done to H? What's the opposite of dividing by 6.3? Multiplying. So if I multiply both